This video is going to go over a few word problems involving sine and cosine law. All right, our first question reads, floating markets are popular ways of buying and selling goods in various countries. In the floating market in Bangkok, one buyer needs to visit 3 stalls. Stall A and B are on the same side of the aisle. Stall C is between A and B on the other side. The distance from A to B is 30 meters and the distance from B to C is 10. Angle ABC is equal to 70 degrees. Determine the distance between the other 2 stalls. All right, so just kind of following with my picture here, what we're going to look at is just drawing in a kind of water aisle, I suppose. And what we have is on the same side, we have stall A and we have stall B. So I'll have stall A here and stall B will be on the same side. What we know is that stall C is somewhere in between A and B, so I'll put it somewhere in between. What we know is that the distance from A to B is going to be 30 meters, and the distance from B to C is going to be 10 meters. Angle ABC, so starting from A going to B, then to C, this one here is equal to 70 degrees. What we want to know is what is the distance between the other 2 stalls, so from A to C. When I'm looking at this question, when I'm trying to decide if I'm going to be using sine law or cosine law, what I notice is that I have 2 sides and I have its contained angle. So this indicates that I should be using cosine law. So first, let's start with our cosine law formula. A squared equals b squared plus c squared minus 2bc cos of A. In this case, what we're looking for is x. And if I wanted to label it as kind of going across from across from uppercase b would be lowercase b. So just kind of redistributing my variables and kind of moving them so that they matches my description. Capital A would be across from lowercase a, and capital C is across from lowercase c. So what I would want to change for is what I'm actually solving for in this question is b. So I have b squared equals a squared plus c squared minus 2ac multiplied by cosine of b. So capital B should always be across from lowercase b. Let's plug in our numbers. So b squared equals 10 squared plus 30 squared minus 2 times 10 times 30 times cos of my angle, which is 70 degrees. Let's plug that into our calculators and see what we get here. What I get for an answer is 794.787. And there's a few decimal places after that. What we have to remember for cosine law is that we want to take the square root of both sides. So then just b is equal to 28.1919. And does it ask us to round? It doesn't. So I'm just going to leave my answer unrounded. And the distance between stall A and stall C is 28.1919 ... meters. Let's try another example. When this particular hole at a golf course was measured, a pivot point was chosen at point B. The total distance from A to B, then from B to C, is 277 yards. Based on the distance, it was decided that this would be a par 3 hole. You decide to play it. Your first shot is perfect and it lands right at B. On your second shot, it veers 20 degrees left and lands at C. Determine the distance your golf ball is from the hole at point C. So in this diagram, what we are trying to solve for is this distance here. We want to know how far away is the ball at point C from the hole, and I've labeled that as D. So first thing that we need to figure out is what it told us is that all the way from A to B to C, this hole is 277 yards. From point A to B is 144 yards. So we can use that information to figure out how far would it have to travel from B to D if it was a perfect shot. We can do that by subtraction. So 277 minus 144 will give us 133. So this is a 133-yard distance. What I know is that it veered 20 degrees to the left, so that's my angle here. And I've given this angle at 100 degrees, and what we're trying to find is x. So deciding if we should be using sine or cosine law. Here, I'm not going to use cosine law because I don't have a contained angle between 2 given sides. So this kind of indicates that I'm going to use the sine law. So when we go to set up sine law, what we're looking for is we have sine of capital A over A equals sine of capital B over B. And we're trying to figure out 3 out of 4 pieces of information so that we can kind of label all of this and put it in and then cross multiply and divide. So when I look for an angle and its corresponding side, what I immediately see is 100 degrees and 133. this is going to be an angle with its corresponding side. So let's input that for sine A over A. So we'll have sine of 100 degrees divided by 133 yards. What this will be equal to is sine B over B. Well, what I'm looking for is a side length. I'm looking for x. So in order to use this with the sine law, I need to know its corresponding angle, which I do. So let's start plugging that in. We have sine of 20 degrees. And in this case, my B value is x. That's the variable I've decided to use here. So let's cross multiply and divide. To get x, what we need to do is multiply the two things that are diagonally across from each other. So we'll have 133 multiplied by sine of 20 degrees. And then we're going to divide by the third thing. So that will be divided by sine of 100 degrees. Let's go ahead and plug this into our calculators and see what we get. What I get for an answer here is 46.1904. And it doesn't ask us to round here, but this is going to be in yards. So our last shot to get to the hole, we would have to shoot 46.19 yards. Let's try one more example. This one reads, Hole 2, known as Pink Dogwood at Augusta National Golf Club, is a par 5, 575-yard hole. With a slight draw off the box, a golfer could reach the green in 2 shots. Suppose your first hit travels 280 yards and your second hit travels 295 yards. Based on the golf club's website, the straight line distance from tee box to hole is 498 yards. Determine the angle between your first and your second shot. What we're trying to solve for is this angle here. We want to know how many degrees difference is there between my first and second shot. Right off the bat, when I'm trying to decide if I'm using sine or cosine law, if I have all 3 sides of a triangle, we want to use the cosine law. So manipulating the formula, here's what we're going to get. We're going to have cosine of A equals B squared plus C squared minus A squared divided by 2 times B times C. When we are looking at this triangle, we need to decide which one is B, C, and A. And it's really important we know which one goes where because it will affect our answer. Because I'm looking for X, the one that I'm subtracting, the side length that I'm subtracting in my formula will always have to be across from the angle that I am looking for. So in this case, A should be equal to 498 yards. When you go to label B and C, these ones don't really matter because I can add in any order and I can multiply in any order because those two properties, or I guess those two operations, are called commutative, meaning that I can do them in either order. So when we go to plug these in, let's just use this one as B. Let's use 295 as C. Let's go ahead and plug this in. So cosine of A is equal to B squared, so 280 squared, plus 295 squared, minus 498 squared. And we'll divide this by 2 times 280 times 295. Let's go ahead and plug this in our calculators. Please be careful when you do this. Please make sure you put brackets around the entire numerator and the entire denominator if you're going to try to do this all in one step. Otherwise, your calculator will take 498 squared and just subtract off or just divide by the 2. It won't divide by the whole number. So let's go ahead and do that. What I get here for a ratio is negative 0.49987. To get just A, we're going to take the arc cos of the other side. So inverse cosine of negative 0.499. Make sure you take all those decimal places, and let's now plug that into our calculator. What we'll get for our final answer here is going to be 119.9915. So rounded to the nearest degree, A is approximately 120 degree angle. I hope this helps you with solving road problems that involve sine and cosine law. Let me know if you have any questions.